Jai Hind to all. Myself Dr. Parneet Kaur. Today I am going to present my topic well-defined learning problems under machine learning. So let's begin with the topic. Now the contents which I will be covering is introduction to machine learning, well-posed learning problems and common issues in machine learning. So let's start with the very first content, that is introduction to machine learning. Now, if we look at the general definition of machine learning, it is an example of artificial intelligence that involves algorithms and data that automatically analyze and make decisions by itself without human intervention. So, if we look at the first 3 lines of this definition, it says that it doesn't involve any sort of human intervention and it helps in analyzing the data automatically and helps the user to come to some conclusion by giving them some decisions. Now, it also describes how computer performs tasks on their own by previous experiences. Therefore, we can say in machine language, artificial intelligence is generated on the basis of experience. If you look at the second 2 lines, that it says that it describes how computer performs the task by the help of its previous experiences. So, in this machine learning, it looks at the previous experiences in order to fetch the information and to perform the relative task. Now, the third statement says that therefore we can say in machine language, artificial intelligence is generated on the basis of experience. So, from these above 2 lines, above 2 paragraphs, it is very much clear that artificial intelligence is used in generating on the basis of experiences because machine learning is altogether a part of this experience. Now, there are certain machine learning algorithms which are quite famous nowadays, like neural networks, random forest, decision trees, genetic algorithm, radial basis functions and sigmoid functions. These are very common algorithms and they are very much in use in machine learning in order to solve some realistic problems. Now, machine learning uses traffic predictions, virtual personal assistant, speech recognition, email spam and malware filtering. It is also used in the field of bioinformatics and very much in use in natural language processing within recent 2 to 5 years. So, if we look at the real-time examples for machine learning, they are like traffic prediction, virtual personal assistant, online transportation, social media services, email spam filtering, product recommendation, online fraud detection, and there are so many other examples also where ML is being used. Now, this is all about the introduction of machine learning. Let's come to the main topic, that is, what is well-posed or well-defined learning problems? Now, if we look at the definition of well-posed learning problems, a computer program is said to learn from experience, which is denoted by a capital alphabet E, in context to some task that is denoted by capital T and some performance measure capital P. And if its performance on task T, as was measured by P, upgrades with experience E. Now, if you see here, this E represents experience and that experience is taken by a computer program which learns and gathers some information in the form of experience. This experience is in context to some task T, that is some work, some program done by or collected by the computer program, and some performance measure, that is P. So, this task T and its experience E is calculated under a performance measure P. If its performance on task T as measured by the P, which P has already measured, get upgraded with experience E. Any problem can be segregated as well-posed learning problems if it has 3 traits. So, now from this above 3 lines, we can say that any problem can comes under the category of well-posed learning problems if it has these 3 things in it. One is it must contain task T, it must have some performance measure P, and it must have some experience E. Now, there are many examples that efficiently defines the well-posed or well-defined problems. To better filter emails as spam or not, this is one of the very common example which comes under the category of well-posed problems, that we want to filter our emails with spam or not spam mails. So if we took or look at this problem, we can classify it into three measures, that is task T, performance measure P, and experience E. Here the task T becomes, in order to classify emails as spam or not. So the task is that we have to check whether the email has spam or not. Then performance measure, the fraction of emails accurately classified as spam or not spam. Now the performance measure that is which is calculated from this problem is basically a fraction fraction of emails which are accurately classified in forms of spam or not spam. The experience which is gathered from this overall problem is observing you label emails as spam or not spam. That is the final experience which is gathered, that we classify the data set or our problem set into a spam mails or not spam mails. That is what the output we get. If we look at another problem, a checkered learning problem, which is also again a very common problem, we have three categories: task T, performance measure P, and experience. The task T is here that we are having a playing checker game, and the performance measure here is that % of games won against opposition or opposer. So what we have to calculate here is that how many games has been won by the player against its opponent. And the experience which we gather from this problem is playing implementation games against itself. So that is what the experience E is calculated, the implementation of games. Again, let's see another problem, that is handwriting recognition problem. So here the task T says that acknowledging handwritten words within portrail. We have some sort of a portrail where we want to find out or acknowledge what words has been handwritten. Now the performance measure P which is calculated here is the % of words accurately classified, that how many number of words has been accurately classified as handwritten words. And the experience which we gather is a directory of handwritten words with given classifications. So that experience which we get is what is actually the directory of handwritten words which are classified, that how many words has been classified under the category of handwritten words. So these are some of the common problems which are taken under well-posed problems. Let's see another example, that is fourth example, which is a robot-driven driving problem. Here we have task T, again performance measure P, and experience E. Now the task, that is driving on public 4-lane highway using site scanner. The task is that there is a 4-lane highway where we have a car which is being driven by a robot, okay, and it is using some sort of site scanners. Now the performance measure which we gather is that average distance progressed before a fallacy. Fallacy means that whether the robot has gathered proper distance before getting failed. Experience. Now what experience says in this is the order of images and steering instructions noted down while observing a human driver. So if we compare the robotic driver with a human driver, we can see here that how many images and steering instructions are accurately being observed by the human driver as compared to the robotic driver. So this is a very common problem. Again, we have a fruit prediction problem. The task is that we want to forecast different fruits for recognition, and the performance measure says that how many fruits, you are able to predict maximum variety of fruits. Suppose we have a bunch of fruits and we have a task to classify or to differentiate fruits or to recognize different kinds of fruits. And the performance measure which comes out to be that what is our probability of predicting maximum variety of fruits from a bunch of those fruits. If we look at the experience E, that says training machine with the largest data set of fruits images, that which machine came out to be getting the largest data sets of fruit images. So this is again a problem related to well-posed problem. Now the sixth problem is face recognition problem. Here the task T is that predicting different type of faces. That is the task. Okay, we have to predict different types of faces of human beings. The performance measure says that what is your ability to predict maximum type of faces, that how many, from here we can calculate the performance of the system, that how many number of faces it can able to predict accurately, maximum number of faces, with which we can calculate its performance, the performance of our machine. And the experience which we gathered is the training machine with maximum amount of data set of different face images that we get. We get a machine, trained machine, which has a maximum amount of data set with different types of faces. So from these 6 problems, we get an idea that what actually is this well-defined or well-posed problems. Now, whatever problems comes to us, first we have to divide it into 3 categories. We have to check whether this problem has all these 3 traits, that is task, performance measure or experience. If it has, then it comes or falls under the category of well-defined or well-posed problems. Now the next task is that we have to design a learning system in machine learning. So how we will going to design a system which learns? So in simple words, when we fed the training data to a machine learning algorithm, this algorithm will produce a mathematical model, and with the help of this mathematical model, the machine will make a prediction and take a decision without being explicitly programmed. So this 4 sentences are very much clear in defining what actually is a learning system. So learning system is basically a system which is being designed by a machine learning algorithm, where it uses a mathematical model, and with the help of that mathematical model, it gives predictions and decisions. Also, during training data, the more machines will work with it, the more it will get experiences, and the more it will get experiences, the more efficient result it produces. It means that our machine has to go through maximum number of experiences. It should get itself resemble with maximum number of similar kind of problems in order to get maximum experiences. And if it do so, then it gives us very efficient result, because it has becomes overall well experienced to give us good results. Sorry. Now, if we look at here in this diagram, we have a data flow type of a diagram where we have the first thing called as a training data, and this training data goes to a machine learning algorithm. Then this machine learning algorithms helps in building logical mathematical model. As we already seen that there are so many machine learning algorithms, the sigmoid functions, the neural networks, the artificial neural networks, and many more, decision trees and many more. So any kind of an algorithm can be applied here according to our problem. Then the next step is that machine learning algorithm builds a very logical type of mathematical model in order to give us the desired output. So if you look at an example, in driverless car, the training data is fed to algorithm, like how to drive a car on a highway or on a busy road or on a very narrow street. With factors, here the parameters which are given under this algorithm is like speed limit, parking, stop at signal, etc. After that, a logical and mathematical model is created on the basis of that, and after that the car will work according to the logical model. Also, the more data the data is fed to, the more efficient output is produced. So it means that we have a car, we are giving it a machine learning algorithm in which we are putting some parameters related to speed limit, stop and signals. And we are giving him the information that how to drive a car on a highway, on a busy street or on a narrow street. And after learning and going through all these model, our car starts working. And if we feed it with more data, it will get more and more experienced and it will get good results. So in this manner, generally, a driverless car has been given or provided with the machine learning algorithm. So it's a very good application of machine learning, that is a driverless car. So if we go for steps for designing learning system. Now we have seen that what actually is a learning system and how we create it. Now basically it is divided into 5 categories. These categories are like choosing training experience, choosing target function, choosing representation of target function, choosing function approximation, and the final design. So these are actually, you can say, the 5 general steps under which this whole designing of learning system falls. So if we look at the very first step, choosing the training experience, what actually it means? It means that the very important and the first task is to choose the training data or training experience which will be fed to the machine learning algorithm. It is important to note that the data or the experience that we fed to the algorithm must have a significant impact on the success or failure of the model. So training data or experiences should be chosen wisely. So what we do, we have to give a very good training data, that is in terms of machine learning algorithm. That's what it says. If we look at the second step, it is choosing target functions. Now we have to choose a target function, which says that the next important is to choose the target function. It means according to the knowledge fed to the algorithm to machine learning, we'll choose next move function, which will describe what type of legal moves should be taken. So target functions means that if the machine has taken one step, then it, with the help of its experience and the knowledge, it will choose the next move. It will see that the next move will be accurate or not by its own. Choosing the representation for target function. Now it will see that what all representation for target function it has to go through. When the machine learning will know all the possible legal moves, it goes for the optimized move, which one is very much correct, which comes or which will give it a very good result or accurate result, okay, or we can say optimal result. It will go with that step. Now the fourth step is that choosing a function approximation algorithm. So as it goes with an optimized step, now what it will do, it cannot be chosen just within the training data. The data has to go through set of examples, and through these examples the data will approximate which step are chosen, and after that machine will provide the feedback to it. And now the final design, it is created at last when system goes from number of examples, like what failures it has achieved, what success it has gone through, it is correct or incorrect decisions or not. Like if we take an example of Deep Blue, it is an intelligent computer which is machine learning based, and it has won the chess game against a chess player known as Garry Kasparov, and it has become the first computer which has beaten the human being. So this machine has learned from its experiences. Lots of data has been fed to it to make it experienced and to make it play like a human being. And because of all these efforts, this machine ML Deep Blue has won the chess competition against this person, a very famous chess player, Garry Kasparov. Now, so after going through all these decision learnings, next is what approaches this machine learning algorithms takes. It can take the approach of decision tree, ANN, Bayesian learning, instance-based learning, that is memory-based learning, genetic algorithm, and relational learnings, which comes under inductive logical programming. So this is a general idea about the well-posed problems and the design of learning system. Now, the next step is that what are actually the issues in machine learning. So while designing all these things, machine learning has lots of cons also, apart from its pros. These issues are, or we can say these drawbacks are, that is lack of quality data, fault in credit card fraud detections, getting bad recommendations, talent deficient, implementation problems, making the wrong assumptions, deficient infrastructure, having algorithms become obsolete when data grows, and absence of skilled resources. We look at these problems one by one. If we look at the lack of quality, it comes under that data can be noisy, which will result in very inaccurate predictions. And this often leads to less accuracy in classification and low quality results. Also, incorrect or incomplete information can also lead to faulty programming through machine learning. Having less information will lead to the program to analyze based on minimal data present. So it means that if we have our data is very much noisy, our data is very much incomplete, then it doesn't give us good results. That is an issue under machine learning. Second is fault in credit card fraud detections. It's an example like although in AI driven softwares, it helps to successfully detect credit card frauds, there is an issue in machine learning that makes the process redundant, that is repetition occurs. It is tough for the system to spot anything without adequate amount of data, hence making them blind to any illegal connections. Detecting fraud without possessing a significant amount of data is close to impossible. So it means that our machine learning algorithms requires good quality of data in order to spot such kinds of frauds. Getting bad recommendation. This is again, you can say, a drawback of ML. That is, proposal engines are quite regular today, and that is, engines basically are softwares. While some might be dependable, other may not appear to provide the necessary results. So these are our search engines, comes under the category of proposal engines, which are being used on large scales in order to get the relevant results related to our problems. And machine learning algorithms tend to only impose what these proposal engines have suggested. So if any modification in the necessity of the result, then recommendation will no use. So it creates a complex algorithm collecting large amount of data and implementing the algorithm, leading to nothing but incorrect results. So it means that if we go for some proposal engines which keeps on modifying, keeps on changing and adding more and more data, then inaccuracy occurs and incorrect results come. So it means that there must be some stability in their results. The next problem is talent deficient. It means that all about numerous individuals are pulled into machine learning businesses. However, there are very less people or expert peoples who work well in machine learning algorithms and gives us reliable results or softwares. Then implementation issue like slow deployment, data security, and although the models of machine learning are time efficient, the creating process of same is quite the opposite. If we look at the data security, saving confidential data on machine learning server is a risk, as model will not be able to differentiate between sensitive and insensitive data. Then lack of data is another key issue which is faced during implementation. So there is not so good algorithms which able to classify that which sort of data is sensitive, very important, least important or not important. Because of this, implementation problems take place. Then making the wrong assumptions. ML models can't manage data sets which contain missing data. So because of this, that contains a huge part of missing data get erased. And if there are a couple of missing qualities, then there is no algorithm which fills the vacant cells. And this approach again causes an issue in machine learning because of the missing of data. Then deficient infrastructure. Then machine learning requires a very good amount of data steering abilities. Inheritance framework can't deal with responsibilities and class under tension. So first of all, the thing is that if we want to work very well in machine learning algorithms, we must have an upgraded system. We must have a very good infrastructure which supports all sort of softwares and tools of ML. Then having algorithms becomes obsolete when data grows. Now, machine learning algorithms will consistently require a lot of data which is being trained. and ML algorithms will be trained over a specific data index and afterward used to foresee future data, a cycle which can only expect with significant amount of efforts. So the earlier accurate model over the data set may presently not be considered accurate at a point where the arrangements of data changes. So it means that previous experiences, previous algorithms doesn't work very well for the coming or new problems. So it means that it should have a very consistent amount of new algorithms. Then absence of skilled resources. Because of the new technologies which are emerging, machine learning and AI, there is still a scarcity of, you can say, manpower and good quality of engineers which can work very well in solving machine learning problems and working with them efficiently and effectively. So data researchers regularly need a mix of space and sight, just as to top to bottom knowledge of mathematics, technology and science, because it requires lot of domain knowledge if you want to get expert. So that's it from machine learning algorithm and machine learning well posed problems. Jai Hind to all.